Good afternoon, everyone. Welcome to our forum on innovation engineering design. Today we are discuss a cruel national challenge, solid waste management in Malaysia. I am Inshira Nuwaida binti Ibrahim, and I have a few questions of the leading the team behind Project 1 of the Smart Waste Segregation bin. The project is our engineering response to promoting Malaysia's goals of achieve a 40% recycle target by 2025. The problem is pressing Malaysia generation approximately 39,000 of the solid waste daily, but only about 35% in currently recycled. At the post season, resources contain a reusable material leading to the heavy of the landfill. Our primary objective is to develop intelligent system that improve the significance of waste generation and minimize the landfill based on the data monitoring technique. Now, let's address to the college challenge. We count the goal is 40% recycling targets. Besides that, what is the single bigger of the smart bins must overcome to our help Malaysia meet the national target. So Vicky, what do you think about the challenges of this national target?
Okay, thank you Sheila for letting the opportunity to talk about these challenges. So the biggest obstacle is public behavioral change. Our bin provides the technology, but we must ensure the bin serves as a awareness tool. Okay, so now the data we gather on usage patterns is crucial here to measure and motivate responsible waste generation. Okay.
Considering the problem in the larger scales, how do you focus on the bin as a single piece in manufacturing scale to target the address waste management crisis effective? So what do you think about this, Shankaran?
Thank you, Shira. So what I'm thinking is the key is the data collection and network development. It's the sensor allow for the real-time monitoring of field levels and segregation accuracy. Deploying these bins across an urban area creates a smart, data-driven waste network, allowing city planners to optimize collection routes and enhance the urban waste management. Thank you.
What we choose replacement plastic over chapter with green material. It could be like briefing of the target sociality risk the made of this discussion materials. So what do you think about this, Rajeshwaran?
Yes, our hierarchy analysis prioritizes the risk of environmental damage from using the virgin plastic as a high societal risk with a risk score of 50. The ethical consideration mandated by the BEM code forced us to choose the more costly but socially beneficial recycled material.
Thank you, Rajeshwaran. We'll go to the chapter production of life cycle, which is PLC. So what do you think about the three pillars of the sustainability, Vicky?
Thank you, Shira. What I think about the three pillars of sustainability is we rigorously apply the PLC and life cycle assessment concepts. Our material selection employ substitution by using recycled plastic for the casing. Before operation, the bin runs on solar power, making it energy efficient. Okay, so this aligns us with the environmental pillar, which is solar powered and also recycled plastic. The economic pillar, affordable production via 3D printing, and the social pillar, promoting hygiene and public awareness.
Oh, that is good, Vicky. So, what do you think? You just say the bin is using solar power. So, what do you suggest to maintain the system energy efficiency?
Okay, so to maintain the energy efficiency, we implement a low power mode supported by a high capacity lithium ion backup battery. The system would prioritize sensor activity and minimal motor operation, with data transmission only scheduled for off-peak hours, ensuring core functionality without grid reliance.
So, do you say the team considering the end of the life stage of the internal components like sensor or microcontroller to complete the full circle flow of the product life cycle?
Yes, we designed the electronic component to be housed in a single, easily detachable unit for simple modular replacement and dedicated e-waste recycling. Furthermore, the main plastic casing is itself designed to be disassembled and regranulated for a second life cycle as a new component.
Thank you, Vigneswaran. Let's go to the safety, ethics, and risk control. So, to address the professional responsibility of this chapter, what did you use to the BME code to prioritize the safety and ethics of the course? I targeting to the Shankaran.
Thank you, Sira. So, as we said about the BME code, we must hold the paramount the safety, health, and welfare of the public as a mandate by the BME Code of Professional Conduct. We address the high priority hazard of electrical shock. The control was an engineering control, implementing and dedicated, extremely secure and fully insulated house unit for all electrical components. This ensures compliance with OSHA 1994.
Okay, do you think this risk that end up the having lost final score?
Okay, from Hijau provides ethical traceability by creating a document record of every hazard considered the assigned risk score and the control measure chosen. The paper trails ensure the decisions were made deliberately and professionally, demonstrating due diligence.
Oh, so you say this is the engineering control that forced to electric shock. Why was the administration control like a warning label to insist for this specific risk hazard?
Okay, when come to that, the hierarchy of control prioritize engineering controls over administrative one. Especially for high risk hazard, a label can be ignored. An insulated housing physically eliminates the exposure to the hazards, providing much higher level of safety that is not reliant on human action.
Thank you, Shankaran. So now we are going to the panel panel 3, which is Rajeshwaran, to finalize the safety discussion with the focusing on the mechanical risk of professional judgment. What do you think about this, Rajeshwaran?
Yeah, sure. We mitigate the mechanical risk of entrapment. This was controlled by a two-part engineering control, a protective enclosure and an interlock mechanism. This interlock cuts power to the motor immediately if the access panel is open for maintenance. This systematic process demonstrates our commitment to ethical traceability and sound professional judgment.
So you think this project are many part of the electronic, Could you identify one of the non-physically like to fall under down the control and how their team going on?
When it comes to the question how the team is mitigated, a critical non-physical risk is data segregation error, which is a functional failure. If the sensor misidentifies the waste, the system fails its core objective. We mitigate this by building a redundancy check into a microcontroller's algorithm and incorporating self-diagnostic routines that flex and sustain a low accuracy ratings to the maintenance team remotely.
Okay, what do you think about the maintenance or inspection protocol is necessary to ensure that interlock remain the complex through by the bin's operation life?
Yeah, we mandate a quarterly preventive maintenance check. This protocol requires a physical testing the interlock switch by opening the access panel to confirm the power cutoff. This documented test is essentially to maintain our OSHA compliance and provide its continued reliability.
Okay, that is good, Dr. Raji. So we move on to the societal environment impact. So what do you think about this concept in Project 1 SDG? So what do you think?
So the SDG for this Project 1 is about the smart bins provides genuine environmental improvement. So the touchless system reduces user contact with waste significantly, lowering health risks and promoting cleanliness. This also serves as an awareness tool. Crucially, by improving segregation, we reduce the amount of organic waste in landfills, which critically reduces the emission of methane gas, a major contributor to climate change.
So, Adrian, what do you think about 5-digit?
This project directly aligned with 5 key SDGs, which is known as the SDG 3 of good health, SDG 7 clean energy, SDG 11 sustainable cities, SDG 12 responsible consumption, and SDG 13 climate action.
So, you think these are 5 SDG, which are the positive challenges of the way we development for this smart bin?
So the changes are that would be the SDG 13, which is climate action. By reducing the amount of organic waste decomposing in landfills, we directly cut down on the emission of methane gas. The reduction in methane is a rapid and highly measurable climate benefits.
Okay, this project are promoting cleanliness through the top of the system. How will be the team measurement in increase the public awareness or response waste generations of social impact that's been interest to create this?
So we can measure this through data analytic collected from the bin itself and increased in the accuracy rate of waste placed into the correct compartments by the user over time, as well as a reduction in contaminated recyclable bins in the surrounding area would serve as key metric for positive behavioral change.
Now we are the conclusion of this the topic of Project 1. So thank you panels to have the team that's for smart waste segregation bin is not just a technical solution but one of the deep communication to signify the ethics, legal components and else for life cycle thinking. That is give the priorities to clean out the more responsibility in the social sociality. So thank you panels and thank you to everyone that's good in this project.